Okay, sure. The calendar, like the schedule dates changed a little bit because I didn't realize you have, let me look it up first. April 7th off. It's a state holiday in North Carolina, but in Ohio, it's not. We have school. Well, YSU has school, but you do not. So you have this Friday off. The project then is not due when like the Friday and then the Sunday. It's due, the main post is due on the 4th and then respond by the 6th. So then you have nothing due on the weekend. Well, attendance would be there also, but that you still could do that early. And we usually do it in class anyways. So that changed a little bit. There is an exam, April, no, be the 31st. The in-class portion would be March 31st. It's just take home would be due on the 2nd. So we'll finish chapter 4 this week. Chapter 7 was more like the ideas for the projects that we've been doing. So I kind of give a little bit of chapter 7 in each of these, but you're not usually tested on it. It's more for the project. But we will finish well, as much as we can at chapter 4. So your test will be over 3 and 4. And I'll have an outline for you to go over. We talked about a take-home portion this time. So maybe there'll only be a few problems for the in-class and then a little more detailed problems that I wanted for the take-home.
I don't know why I thought the exam was this Friday.
Oh, no, that was one thing I had to move my other class though, because their exam was on the 7th, which you don't have school. But yep. So it's, and you know, I think when we were talking one time, I said 2 weeks, but I think I counted spring break.
Okay.
Yeah, I think that's what happened. Sorry about that. So it is the 31st. The in-class portion is on the 31st of March. And then your final is May 10th at 8 a.m.
What is the final going to be like? Is that going to be over everything or just
No,
5 and
it'll be
6?
similar to your test, so it'll just be over 5 and 6. And we will review just like we review for your test. So your final is going to be like the exam. And I will make like a take home and an in-person one. That way the more detailed problem, if I have any, would be the take home. And that way we can even discuss it in class before you turn it in. And then the in-class will be just basic problems and we'll review ahead of time. You can use your notes, your formulas. Any questions? So difficulty-wise, these will be no harder than the first exam. So either that or simpler, since part of it will be take home. But any questions? Okay. No. Oh, first homework. So on the homework, attendance, I guess is what I mean. There's only one attendance problem. I saw this in chapter 7 and I thought it was kind of interesting, and it's not really math related, but if you can find something math in there, that would be nice. Use numbers with it. But it says investigate what natural disasters are considered potential risks in your community. Now, by your community, it's up to you if you want to use Appalachian, or if you're coming from somewhere else that's your hometown, then use your hometown. It's up to you which way you want to do that. What are the recommendations for disaster preparedness in each case? The U.S. Department of Homeland Security provides information at this website, and just write a paragraph about it. It doesn't have to be anything long. Just the natural disasters in my area, like the biggest natural disaster for my area would be tornadoes. And so how to be prepared for that. Now, in some areas, not in my house, but probably about maybe 5 miles from my house, there's a development that every time there's heavy rain, they flood. I mean, you could put a boat on the street, and they have that a couple times a year. So then flood would be one of theirs. So see what your natural disasters are in the area that you either your hometown or Appalachian, either one. And just write a paragraph about it. Any questions on that? So that will count for all 4 days. Any questions? And then if you notice, the project went up. This also came from chapter 7. After each, like the homework for each one of these sections was this. And so I thought it would be good to do. Now, you only choose one of them, whichever one you think's interesting, and then you read in that section about it. Identify the use of any, and we're going to talk about what a rhetorical appeal is today, and explain them. Identify examples in this piece of quantities put in human terms. So there's already quantities in there put in human terms. Explain what they are, and then create one of your own. So if they took, let's see, what's one of these? And they talked about the area that was burned from a wildfire, and then compared it to maybe so many football fields. Then you would compare it to something else. So find examples where they compare it in human terms, and then create another comparison for it. And then find or create a graph showing more information on the topic. So go on the internet and use whichever topic you have and find more information, like extend on their article by using a graph, or if you're not finding a graph, then use some other numerical values that you've found online. But I thought it'd be nice to put the graph in there since we're doing the humanizing terms. We put a graph. Post onto the discussion board by April 5th. So the main post is, sorry, April 4th. The main post is due April 4th. If you don't put it on, then you lose the 5 points. Respond to 3 other students. Now it says to try to choose ones that you didn't do. Now, of course, if there's only everyone does all the same one, then you don't have that option. But if you did the risks of wildfire, try and do one of each of the other ones. So then you're learning more information. But if everyone's doing the same one, then you can't do that, and that's fine. But try and do the opposite ones of yours, if possible. Or maybe one of yours and two of the other. That would be nice too. Any questions on that? But if they're all the same, I will not take off for that. It's just, if you can, I'd like you to see the other articles also. So that way you're getting a little more information. Any questions on that? Besides what the rhetorical appeal is. Okay. Now this is on As You Learn also. It's under outlines. Rhetorical appeals. So that's what this is. So it is up there. There are 4 that your book uses. The first one is logos. It's appeal to reason. And these are all Greek words. Logos is the Greek word meaning a word or reason. In rhetoric, it's an appeal to logic and reason. It is used to persuade an audience by logical thought, fact, or rationality. Logos can be useful in persuasion because if you can prove an argument through the logical and sound reasoning, your audience is more likely to be persuaded. So it's something you're proving or showing it to be a fact by math can be one way, graphs can be another way, a survey can be another way. So an example in an article could be, we've done the calculations based on the best available data. The results are completely clear. Oh, I think I just forgot this. But it's something that shows that we did the math, we figured it out. Any questions on that? So that one is one where logic, reason, a hypothesis that was solved. It's just facts. The next one, pathos, is an appeal to emotions. This is used a lot. Pathos is a Greek word meaning suffering or experience, and it is used in persuasive speech as an appeal to the emotions of an audience. Pathos is the way of creating persuasive argument by evoking an emotional response in the audience or the reader. You can use pathos when trying to persuade by appealing to an audience's hopes and dreams, playing on their fears and worries, or appealing to their particular belief or idea. An example, I love to hike at night under the stars, and I want my children to be able to enjoy hiking too. Make no mistake, unless we control carbon pollution, our children's future is threatened. So something that appeals to sympathy, the animal rights, they show you videos to try and persuade you emotionally to give money for them by showing different animals that need help. So it's a form of appealing to your emotions. Any questions? Ethos is an appeal to credibility. Ethos is a Greek word meaning character. In terms of persuasive language, it is an appeal to authority or credibility. Ethos is a means of convincing an audience of the reliable character or credibility of the speaker or writer. Sorry. It is an important tool of persuasion because if you can get an audience to see you or your argument as a credible or trustworthy, it's much easier to persuade them. Dr. X has spent her entire professional career in climate science, writing 3 books and over 200 peer-reviewed journal articles. You can trust what she has to say. And if you think about in courtrooms, they're always bringing a credible witness, someone who specializes in a certain area, fingerprinting, I don't know, there's a lot of different things. And so that is one way to persuade people, is by having a credible source. Any questions? Now, if you look online, these 3 are the most often. This one your book uses, it's not used as much. For some reason, it didn't show up until I actually typed it in. But if you just type rhetorical appeals, it wasn't popping up. Kairos is appeal to timeliness. So it's when things happen, or the timeline. Kairos is rhetorical strategy that considers the timeliness of an argument or message, its place in the zeitgeist. The term comes from the Greek word right time, opportunity, or season. Modern Greek also defined kairos as weather. A kairos appeal depends on a great deal of knowing which way the wind blows. The decisions we make today will determine the future for generations to come. Let's be sure we get them right. So they're talking about time. They could talk about the seasons, or how things are changing during time. You could see a timeline in there, a timeline graph. So this one, I think because it's talking about time, it's not used as much. Like reading what they wrote here, the decisions we make today will determine the future for generations to come. Yeah, but it's not as appealing as the other 3. And sometimes maybe this combined with one of the other ones, because a lot of times you're not just using one. And that's why in the project, there'll be more than one used. And you don't have to find every single one, at least find 2 for the project. Don't get nervous what if I missed one? I want at least 2. I know each article has at least 2. It probably has a lot more than 2, but you don't have to find them all. Any questions on that? Positive? Now that you know what this is there any questions on the project? So you pick only one of the articles, and then make sure you use the title. That way students know which one is which. Now you don't have to type this whole thing. Just type, like for this one, the changing risks of wildfire, or this one, nuclear power is a commitment to the future. So for your title, use the title here. That way you can find the ones that are different from yours. Any questions? Positive. Okay. We talked about last class, I had said to read this. I wanted to do these problems though, but is there any questions? Growth rate, and there'll definitely be one of these on the in-class part of the exam. Because absolute change and relative percent change, and that's what this is. Growth rate is your relative change. New minus original divided by original. So growth rate is just relative change. And the growth rate of a stock over time interval, also known as relative increase in the stock, and it might not always be an increase, it could be a decrease over time. And this is the formula. The new minus the original divided by the original. Growth rate is a pure number and the same as relative percent change. So remember, this doesn't have units with it. If you multiply by 100, then it's a percent, but it doesn't include, like if you were talking about inches or thousands of people, those units get canceled. And that's what it means to be a pure number. It doesn't have units with it. It can have a percent if you multiply it by 100, but it will not have units. Suppose that a population of bacteria growing in a culture is described by a logistic model. At successive time intervals, the population is given in the table below. Compute the growth rate for each time. So at time 0, it had 25,000. 20 minutes later, it's in minutes, it had 35,400. And then 40 minutes later, and so we want to find the growth rate. Now it can be a decimal or a percent. I like to use the percent. 0.38 is not as easily understood as 38%. So this is saying that it increased by 38%. Now, when you're finding this rate, you're using the initial value. So for this one, it was the, let me write it on paper. To get the 38%, it was the 35,400 minus the original. 1, 2, 3. And then I made it a percent. So I multiplied by 100. Any questions on that? The biggest thing is plugging it in. So make sure you're typing it out and plugging it in your calculator to make sure. Okay, I got a different answer this time. 35. Are you getting 41? I don't know. Type it in again. I don't know how I got that. 35. Okay, so for this one, I don't know if I took it from the book or what. But you should be getting 41.6%. Is that what everyone's getting? Yeah, that's what I got too. I don't know. I think I just took that from the book, but. Now for the next one, notice this is the initial value. So you're still using the 25,000. This is your initial value. The only thing that's changing is the 35,400. So for the next one, it would be the 46,600 minus the 25,000 divided by the 25,000 times 100. I'm getting 86.4. So after 40 minutes, the original population has increased by 86.4. Any questions? So then this 86% is not the next 20. It's over the entire 40 minutes because you're using the initial value of the stock. So then for the next one, where it's 61,200, so then this just changes. Now this one went up more than 100%. Now, some calculators, most of them, you can bring like your answer back up. So this is the whole thing typed. If I hit on mine, it's second and enter. It brings the problem back up, and then I just have to change that first number. The 61,200 changes to 77,000. And so then I just go up there and I change it to 77,700. And it more than doubled, 210.8%. Any questions? Is everyone getting those values? Well, the next part I had asked you to read, and there's some main points I want to go over. The carrying capacity of an environment for a given biological species is the largest population that species can sustain in the long term by the resources available. Like the one island where they brought the deer, the carrying capacity for the deer, it wasn't enough. Maybe you could only have one or two, or maybe you couldn't have any, depending on the resources that were there, and things were not growing fast enough. And so your carrying capacity is how many you can have on that. You see it a lot in ponds. They can only have a carrying capacity of so many fish. So if it's really low, then they'll ask you to do catch and release. If it's really high, they'll ask you to catch and keep it so they can get the capacity down. But it's how much that environment can hold with that many. And even deer in our area, they do a lot of hunting, especially like maybe an hour from my house. It's in Pennsylvania. They have the first day of hunting, they close the schools because there's that many that hunt. But then they'll tell you you can only catch a buck or a doe or one, or maybe it's too overpopulated and you're allowed to catch more than one, maybe two or three. Because of the carrying capacity, how much the area can have. I think the deer I live near a park, and I think it's getting over capacity because every year there's more and more deer I see in my yard. And that's what happens, it gets overpopulated. So it's how much that environment can hold. I guess the fish one was on here. The ideal carrying capacity was invented by ecologists studying plant and animal populations. For example, a fish farm might be said to be carrying a capacity of 100 tons, meaning that its system can support healthy population of fish in various stages of development whose total biomass is 100 tons. If the fish population grows larger than that, the environment will be degraded, perhaps severely. So this tells you once you've reached that capacity, if you go larger, then your environment will not sustain you. Ecological footprint, it's kind of like the carbon footprint that we did. Carbon footprint only takes into account the carbon dioxide that you put into the environment, where this takes a lot more. It talks about the plants that you use, the water that you use, the animals that you use. And so it takes in everything on the Earth's surface rather than just carbon dioxide. So that's the difference. It's more of your whole lifestyle. And that's what that says. We did the carbon footprint. Earlier we did the carbon footprint. Carbon footprint deals with the resources, but it only talks about the carbon dioxide that is for the greenhouse gas. So if you wanted to do another one, you just type in ecological footprint, and it'll ask you all the similar questions, but then it will tell you everything rather than just carbon or greenhouse gases. It tells you everything. And then it tells you how many Earths and things like that. So it tells you the same kind of thing, but it's talking about everything, not just carbon dioxide. Not all parts of the Earth's surface are equally productive. The footprint is expressed in terms of global average acres. One can say, therefore, then your ecological footprint is 17 global average acres. The same idea is sometimes expressed and I remember from your project, some of you had put how many Earths. It told you 3.5 Earths to support everyone on the planet, or to support you, and then think about everyone on the planet. Most of the ecological ones tell you you use this much. So in order to support everyone, we need 3.5 Earths, which we know is not possible. We only have one, and we need to take care of it. But any questions on that? So carrying capacity, and I believe they give us a formula later, is how much we can hold in a certain area. And ecological footprint is like the carbon footprint, only it takes into account everything: plants, animals, water. This gives a sense of the idea of overshot. We only have one Earth, not 3.5. If my lifestyle requires more than one Earth to support it for everyone, then it's overshooting our carrying capacity, because our carrying capacity is one Earth. And if we need more than that, then there's too many people, and we have to find a way to save our resources so we can sustain that many people. Some, though, would say the notation of carrying capacity is not appropriate when applied to human beings and their activities. After all, the fish in the fish farm do not have the ability to improve their environment by choice and creativity. They're limited. We are resourceful. So we can change our habits so that we can live within our one Earth, where fish cannot do that. And so we have to make sure that they do that. Not that we have to kill them. You need more pond or bring them some to another pond, but something has to be done. And so we have to take care of that. But ours, we can change things. And when we don't, certain things like COVID does. I mean, you get overpopulated, and then there's all of a sudden some disease, which COVID seemed to be the worst that we've had in a very long time. Populations, if you look up the states during COVID, I think it was 80% of them, the population did not increase in a couple years. It actually decreased, and that was the first time since they kept track of population. So it did make a big difference. Now we're growing again. But things like that also happen to help take care of the population and make it smaller. Any questions so far? These are some things to think about that I thought were interesting from your book. Julian Simon, a professor of business administration at the University of Maryland and cornucopian economist, wrote, this is a link if you went on to the computer, on to the book, if you wanted to read more. Because we expect future generations to be richer than we are, no matter what we do about resources, asking us to refrain from using resources now so that future generations can have them later is like asking the poor to make gifts to the rich. Any thoughts on that? So what she's saying is people feel, why should I worry about the future? They're going to be wealthier than I am now. Let them worry about it. Yeah, they're not going to be wealthier than if they can't survive. So if we use all of our resources now, there isn't going to be a future. And that's kind of what she's trying to tell you, that this thought process doesn't make sense, that they will be richer later, or make more than me. So then let them worry about it. I don't know. Do you agree with that? Anyone? I don't agree, because we are giving you gifts. Yeah. So I completely agree. Our gift is sustainability so that futures can still thrive. And if they are making more money, then they need to find more ways to help their future survive.
kind of selfish.
You're selfish. It doesn't have to be a monetary gift. It's just a plant a tree every year. There's lots of things you can do like that. Even at different parks, you can plant a tree in memory of somebody, and then they put a little plaque. And not only do you have the memory, then you also have helping the environment with climate control. Any questions on that? So I thought it was an interesting one to look at. This one kind of was too. The Donella Meadows Project Mountains, an online archive of Meadows' work on separate thinking and sustainability. They attribute the following quotation to her. Guiding message. We humans are smart enough to have created complex systems and amazing productivity. Surely we are also smart enough to make sure that everyone shares our bounty. And surely we are smart enough to sustainability steward the natural world upon which we all depend. So what do you think she means by that? I mean, we are able to create complex systems. We're able to go to the moon. We should be able to find a way to sustain our environment and make sure it keeps growing, and people shouldn't. I think it also kind of means that we shouldn't have people in living on the street. We shouldn't have people who don't have a home. I think she's talking about more than just sustainability in this one. My daughter, in one of her education classes, I don't know if she watched a video on it or if they just talked about it, but there's this one scientist who did a study, and he said that if the upper class gave even just a part of their money to the poor, there would be no poor class. Everyone would be a middle class. But the problem is that the people who were wealthy don't want to lose the people they're hiring to work for them. Because if everyone's at an equal amount, then you're not going to have people who want to do cleaning and things like that, because they're all making enough money. And so what they do is, say you maybe you need to make $45,000 to be at the middle class per person, and you're only at $30,000. The government pays you the extra $15,000 to be at middle class, so that everyone is at the same level. And maybe she means something like that too, that we need to share our bounty. I don't know. That's a thought. But any questions on it or thoughts about it? And you could type it in the chat. No. I just thought it was kind of interesting, but I mean, I wouldn't test you on those. It's just a thought. Thank you. I agree with what I'm saying too. But unfortunately, I'm not one of the wealthy or upper class, so I don't have any money to give. But I don't know. There should be a way that everyone is equal. Logistic model. A stock in a stock flow system is governed by a logistic model. If the net flow into the stock is proportional to the product of two quantities, the level of the stock and the amount by which the stock level is below the carrying capacity. To write in an algebraic formula, if S is the stock level, and C is the carrying capacity, then the net flow is this formula. And K is a constant of proportionality. That would be given. It is often helpful to express this quantity and the net flow in different forms. Sometimes they use this. And we'll do, not today because it's just about over. We'll do some problems using this. The logistic model summary. The rate of the constant is R and the time step is T. The carrying capacity C. With these parameters set, the net flow of the stock at each time step is this. So if we said it was daily, then this would be the value each day. If we said monthly, then this would be the each month. Every 10 minutes, then it'd be every 10 minutes. So the time step is it's continuing, or this proportion each, whatever the units are. And S is the starting at the beginning. Look at that. I don't know where the other part is, but we'll stop there. Any questions? So we'll go into the problems next class. Any questions? Okay, if you do not have any questions, I'll see you tomorrow.
Thank you.
Thank you. Have a nice day.
You too.